Assalamualaikum and good day. Now we are at workshop UniKL MSI. Here we have safety corner. The information that we can get from this safety corner are safety policy, safety and health organization chart, emergency response team organization chart, assembly point, emergency contact number, emergency evacuation map, and also others. During COVID-19 pandemic, we have prepared hand sanitizer and placed it at suitable area. We also provided bunting, banner and poster to ensure students wear it at all the time during this pandemic. Safety requirement to enter workshop during practical class are mandatory to wear safety shoes. For visitors, they must wear closed shoes during visit and they must walk between these two yellow lines for safety purpose. There are safety signage at workshop and lab to ensure students keep in mind about safety requirement during practical class at workshop. For every lab, HSC has provided emergency evacuation map, emergency contact number, and fire action plan, also evacuation procedure. There are first aid kit at workshop and lab. It will be used for students to use any incident happen to them during practical class.
Okay, Assalamualaikum. Welcome to Vibration and System Dynamic Labs UniKL MSI. Okay, so this lab used for the subject noise and vibration, and also used for the engineering mechanics 1 and engineering mechanics 2. Okay, so for the subject noise and vibration, we have 5 lab and 1 open-ended labs. So one of the lab for the noise and vibration, we will use sound level meter. So this is the sound level meter, so the brand of the Svantex. The sound level meter will be measure the level of the noise. So student will do the measurement from the source of the noise. Okay, we have 2 type of the sound level meter. First is the Svantex with the 1/3 and 1/6 octave, and this one is the general sound level meter with the high amplitude noise. And then the others equipment lab for the noise and vibration. So this is the basic setup for the lab 1 for the vibration and noise, which is the measurement of the damping ratio. So student will be given the plate, and then student will knock the plate and then measure the response of the vibration, and then do the calculation to determine the damping ratio and also to determine the natural frequency of the plate. Okay, and then the third lab is a model analysis lab. So this is the setup for the experimental model analysis. So we'll be using LMS data acquisition system and then connected to the LMS test lab. So student will measure the model analysis natural frequency of the plate in the 2 condition, fixed and also fixed free. So this is the example of the result obtained from the experimental. So this show the mode shape of the plate during the natural frequencies. Okay. And then the next lab for the noise and vibration is the measurement of the gearbox or gear system vibration measurement. So we'll be using the natural instrument data acquisition system connected to the software of the lab view. So the student will do the measurement to determine which component or which gear is broken. Okay, and then this is the lab for the open-ended lab for the noise and vibration. So the student will be given unbalanced mesh motor. So the motor will vibrate, and then the student needs to determine is it the system is vibrate on the forced vibration or natural frequency vibration or resonance. So student need to determine the natural frequency of the system. So the determination of the natural frequency can be done using the experimental model analysis of LMS, or student also we can do using the bump test. So there is two methods to determine the natural frequency. So student need to determine which method they will be using, and also student need to suggest how to reduce the vibration after they determine the natural frequency. So they need to suggest the method to reduce the vibration and test their method, is it successful or not to reduce the vibration level. Okay, thank you.
Hi, welcome. This is automotive structure lab, and for this BME, for this Bachelor of Mechanical Engineering program, we have several experiments conducted in this particular lab. So let's go inside. So we in this particular lab we have similar like other labs. So we have all these safety poster, safety features, and we have all these if there is an emergency, what the number should we contact. Okay, for this particular lab, the subjects that we are covering is on the solid mechanic or strength of material. So we have few equipments for the investigation or the experiment on this strength of material or solid mechanics. So we have truss structure, in which for this truss structure, so the student needs to measure the force, internal force developed in this particular members when there is a loading. When we put the loading, and then they need to measure the compression or tensile force in the particular truss member. So that is the experiment for this particular force, and then from that they can obtain the stress. Once they obtain the force, they can calculate for the stress in this particular truss structure. Okay, the next apparatus is for torsion. So this is for torsion and deflection. So the student will do the loading, torsional loading, and then from that they need to measure the deformation, and in some cases they can do the torsion until this sample will break. So in certain cases, so this is for so that they can then calculate the shear stress. Okay, the next one is for shear force and bending moment. So in this particular apparatus, the student will have this loading. From that, there is for this particular beam, there is already a cut here, in which they need to find the force, internal force here, and then from that they can relate internal shear force here, and then they can relate with the bending force. So this for this particular labs, for this strength of material labs or solid mechanics lab, so they are covering the normal force, the shear force for the shear torsional force or torsional stress, and also this shear and bending moment. So they can also sort of draw the shear and moment diagram, and they can also have several loading or distributed loading, and so there are a lot of experiments that can be done by this apparatus. Okay, so thank you very much.
Okay, Bismillahirrahmanirrahim. Assalamualaikum. My name is Khairul Syarif bin Syafi'i. I'm a PIC for this lab. This lab is we call a fluid mechanics lab. So please come inside. Okay. Okay, so this is a safety signage. For technical officer from for this lab is Mr. Asrawadi, Mr. Asrawadi. Okay, this is the safety for this lab. For example, the procedure, the asset listing, and then how to use the fire extinguisher, and the hotline. If we have emergency case, so we can call this agency. Okay, this lab, fluid mechanics lab. From this lab, we use for 2 subjects for bachelor mechanical engineering. Fluid 1, we use around 4 labs from this lab. Number 1 is fluid hydrostatic. This one, hydrostatic bench. This is we use for fluid 1. So we have 3 experiments from this lab. This lab actually the 3 assignment we use. For example, want to calculate hydrometer used to measure the density of a substance. For example, we have a glycerol, we have hydraulic oil and water. This is very fundamental. This is about the properties, how to calculate the properties of fluid. Okay, experiment number 2 is about the fluid friction. Fluid friction, this one. So from this fluid friction, actually we have two lab ataupun or two tasks here. The elbow, the minor losses, we want to calculate the effect. We have 45 elbow, we have a T joint, and then we have a meter band. So how to calculate the minor losses from this lab? Okay, the second task actually when we want to measure the fluid friction inside the pipe when we use various pipe diameter. For example, the first one we have 10.3 mm, and then 13.5, 17 and 18 mm. So when we probe the digital pressure meter from this point to this point, and then we can calculate the pressure losses. So student also need to compare by using the calculation from the experiment and calculation. Student need to verify. Okay, this is experiment number 2 from fluid 1. This is flow measurement also for subject fluid 1. When we want to compare the performance of venturi meter and orifice meter, student need to measure the high variation from this tube. We call it this one tube manometer. So student need to calculate the high variation. So student also need to compare with the calculation. This is experiment number 3 for fluid 1. The last but not least, this one. Okay, please coming. Okay, the last one, this lab. for subject fluid mechanics 1. This lab we call pressure measurement apparatus. So this pressure measurement, student need to compare the difference by using inclined tube manometer, single manometer, and U-tube manometer. This one also student need to compare with the calculation. We use pressure equal to rho GH, and then this one we have the measurement here, so student can calculate H high, and then this one the angle, and then compare with the calculation. So this is last lab for fluid 1 subject. And then the other three apparatus that we use for second subject is fluid mechanics 2. Fluid mechanics 2 is more on turbo machinery, but for fluid mechanics 1 is more on fluid static and then fluid dynamics. But for fluid dynamics we focus more on incompressible flow. But for fluid mechanics 2 we focus, for experiment we focus on turbo machinery. So for turbo machinery we have two parts here, pump and turbine. So luckily in UniKL MSI we have both type of turbine. We have reaction turbine and also we have impulse turbine. So this type of turbines is commonly used in hydro power plant in Malaysia. Okay, the first type of turbo machinery we use pump. So this experiment, student need to compare the performance between series and parallel configuration pump. So when student compare series and parallel, so student to need to justify about in terms of head and flow rate, which one is double and why. If a flow rate double, why head is constant. So student need to figure out by using this experiment. Okay, experiment number 2 for second subject, this one. Okay, just now I mentioned we have two type of turbine. So commonly that this turbine used in Malaysia, TNB. I visit some of hydro power plant in Malaysia. Normally they use Francis turbine. Okay, Francis turbine and Pelton turbine also. Okay, Pelton turbine normally we use at the upstream region. And this is Francis turbine. Student needs to find out the optimum point from certain configuration. So this configuration actually we can vary the setup. For example, this one we try to vary the setup by using this guide vane. Okay, this guide vane, for example, from this one to this one, student need to find the optimum point. So the optimum point actually student need to use this computer. So we have a software here. So same with Pelton turbine, we have a software inside the computer. Student need to find out the optimum point from certain configuration. This one we use a guide vane to vary the setting for this experiment. But for this Pelton turbine, we use this valve to control the pressure. So the difference between Francis and Pelton, the Pelton one we need to convert first this flow energy to the kinetic energy. But this one we use both kinetic and flow energy to convert or to harvest the energy from the water. Okay, I think that's all from me.